Welcome to my presentation. In this presentation, we shall see examples on operations with limits. So let us take an example, and then in this example, we want to find the limit of this function x to the power of 3 minus 1 divided by x minus 1 as x approaches 1. This is the question we have. We want to find the limit of this. So the way we want to solve this problem is we want to be able to write them out in these different steps. We are looking at the numerator part, x cubed minus 1. It is in the form of difference of two cubes. So if I were to take the numerator, this is in the form x cubed minus 1, which is same as 1 cubed. We know from the difference of two cubes, if we have a cubed minus b cubed of that kind, we can expand it out as follows. A minus b times a squared plus ab plus b squared. We can write the expanded form of difference of two cubes as shown here. We can apply that same concept for x cubed minus 1 cubed, so therefore we can write this expanded in this expanded form as follows. X minus 1 times x squared plus x times 1, which is going to be x, plus 1 squared is going to be equal to 1. So the expanded form of x cubed minus 1 cubed is going to be equal to x minus 1 times x squared plus x plus 1. So therefore, we can now rewrite the given problem in this manner in step number 2. Limit of this function, instead of x cubed minus 1, I'm going to write it in this expanded manner, which is going to be x minus 1 times x squared plus x plus 1, the whole thing divided by x minus 1. As we said, if we have terms which are similar in the numerator and denominator, we can cancel them out. In this case, x minus 1 is similar, so therefore we can cancel it out. When we simplify that, this is going to come out as limit of this function x squared. I'm sorry, let me write this a little more clear here. We can write this one as x squared plus x plus 1 as x tends as x is approaching 1. Same thing here, as x is approaching 1. Now, as step number 3, we're going to expand this trinomial out as follows. Limit of x to the power of 2 as x approaches 1 plus limit of the function x as x approaches 1 plus limit of the function 1 as x approaches 1. So that is what we have. And now as step number 4, we can come back and then substitute the values of the variables. As variable we see x, we're going to substitute the value of 1. So therefore we can write this as 1 to the power of 2 plus limit of the function x as x approaches 1. We'll substitute the value 1 for x, so therefore 1, plus the limit of a constant number is going to be equal to 1. So therefore 1 squared is 1 plus 1 plus 1, which is going to be equal to 3. So when we evaluate this limit, x cubed minus 1 divided by x minus 1 as x approaches 1, the value of that limit is going to be equal to 3. So that is the way we want to use the operations of limits to be able to solve this problem. Let us take another example, and then in this example we want to find the limit of this function. Limit of x squared plus x minus 6, the whole thing divided by x plus 3, as x approaches negative 3, like that. Okay, so to be able to solve this problem, we're going to break it down into these different steps. Step number 1, we're going to look at the numerator part. We'll take the numerator and then factor it. We have x squared plus x minus 6, and if using our factoring techniques, if we were to factor this, we're going to come out, we're going to arrive at x minus 2 times x plus 3. X minus 2 times x plus 3 is the factored form for this trinomial, x squared plus x minus 6. Therefore, we're going to rewrite the given problem in step number 2 as follows. Limit of this function, instead of x squared plus x minus 6, I'm going to write it in its factored form, which is x minus 2 times x plus 3, the whole thing divided by x plus 3. As we said, as x tends to negative 3. We said if we have terms in the numerator and denominator which are similar, we can cancel them out. X plus 3 and x plus 3 cancels out. So therefore we are left with limit of this function x minus 2 as x approaches negative 3. Now, as step number 3, we can write this given function as follows. Limit of the first function, which is x, as x approaches negative 3, minus limit of the constant number 2 as x approaches negative 3. Now we are ready to substitute the values of x, and step number 4 we will implement that. Limit of x as x tends to negative 3, we're going to substitute the value of x as negative 3, and then minus the limit of a constant number is going to be the constant number itself. So therefore, when we simplify this math here, negative 3 plus negative 2 is going to be equal to negative 5, and therefore this is where we want to leave it. So when we wanted to evaluate this limit, x to the x squared plus x minus 6, the whole thing divided by x plus 3, as x approaches negative 3, we factored the numerator part of the limit, and then we were able to cancel out the terms which are common in the numerator and in the denominator, and then we were able to apply the operations of limits, and then we were able to arrive at this answer, which is equal to negative 5. This is the way we're going to use going to solve problems using operations with limits. In my next presentation, we shall see more examples on operations with limits.